Hi everyone. So let's look at the question one for homework six. So first, let's look at the question. So the question was if x and y have joint density function of this one plus xy by a and mod of x less than y and mod of y also less than y, then we need to find out the constant of a. So this is the first part. So we know that if we integrate from the limits, so the probability density function that would be 1, so we take integration from -1 to +1 as how this limit comes -1 to +1 because mod of x and mod of y both are less than 1, so we know that x and y are actually lies between -1 to +1. So we take the limits -1 to +1 and we integrate it, and after some normal calculations we find out that the value of a is actually 4. So this is it. So now let's look at question 2. So part 2 was to find out if x and y are uncorrelated. So what do we do? First we find out if y of y. So again we take the limits from -1 to 1 and integrate it over fxy and find out that the probability density function for y is nothing but half. So that is a uniform distribution. So similarly the probability density function for x would be similarly half. So both of the x and y follow actually uniform distribution. So now if we take the expectation of x, so as x into fx, it's an odd function though, so the in expectation of x comes out to be 0, and similarly the expectation of y would also come out to be 0. So now we try to calculate the expectation of xy, and the expectation of xy, you put the values of fxy and integrate it over -1 to +1, and we find out that the expectation of xy is actually 1 by 9. So for two variables x and y to be uncorrelated, we know that expectation of xy has to be equal to expectation of x into expectation of y, but this is not the case. So x and y are actually correlated, that is, they are not uncorrelated. Now let's look at part 3. Part 3 was to find out whether x and y are independent or not. So this is pretty simple actually, because we know that if two variables are independent, then they are uncorrelated, but if they are not uncorrelated, they cannot be independent. So this is pretty simple. X and y cannot be independent. Now the fourth part was to find the joint density function of x square and y square. So we just take two auxiliary variables z equals to x square and w equals to y square, and we find out the Jacobian. It comes out to be 4 of xy, 4 into xy, and now there could be four roots for actually z x square and y square. So what could be the four roots? The four roots could be actually plus root over z, plus root over y, plus square root of z minus square root of y, plus square root of z minus square root of z, plus square root of w, and minus square root of z and minus square root of w. So we take the summation of all the four solutions and we find out that the joint distribution of zw equals to 1 by 4 into square root of zw. So now let's look at the fifth part. The fifth part was to find out whether x square and y square are independent or not. So similarly, if z of z equals to integration of 0 to 1, 1 by 4 into root over zw, and how this limit comes to 0 to 1, this is nothing because x square, so x lies between -1 to +1, so x square naturally lies between 0 to 1. This is pretty simple. So the limit comes from 0 to 1 and we integrate it over, and we find out that if z of z equals to 1 by 2 root z, and similarly if w of w equals to 1 by 2 root w, and f of zw equals to, as z and w are independent of each other, so f of zw equals to f of z into f of w. So that means they are independent of each other. So that's it for question number 1, I guess. Yes, that's it. Thank you.